Hi all, welcome to the first session of the course Computer Organization and Architecture. I am Priyanka KODURU, Assistant Professor in the Department of Computer Science and Engineering, KMIT. Before starting the course, let us all see about the objectives of the particular course and what are its outcomes. So coming to the course objectives, course objectives are something, what is the objective that you are going of the particular course. So with the help of the course Computer Organization and Architecture, it will help you to understand the basic concepts of a computer and as well as the principles of computer organization and architectural concepts. And it will also help you to understand the instruction sets. What are the instruction sets present in your computer, instruction formats, and various types of addressing modes. And you can able to understand the basic data representation, how the data is represented internally in your computer, and how can you perform a manipulations on your data that is stored in the computer system through the concept of computer arithmetic. And moreover, you are going to explore about the different types of memory organization, which will help you to understand about different types of memories that are available in a computer system, as well as the input output organization. And finally, it aims you to understand the concepts of pipelining techniques, which is one of the technique that is used in a computer in order to execute the instructions of your program. Next, coming to the outcomes. What are the outcomes of a particular course? So, as a course computer organization and architecture, the main outcomes are the understanding the basic instruction sets and how do they have an impact on the design of a processor for a computer system, as well as demonstrating an understanding on the design of various functional units of a digital computer system, and evaluate the cost performance and design trade-offs in designing and constructing the computer, including the memory unit of a computer. As well as it also helps you to design a pipeline for a consistent execution of instructions without hazards, and perform different types. You can recognize and manipulate or perform different types of manipulations on the numbers which are stored in the digital computer, and use string processing in different applications. So these are the outcomes at the end of the course. You are going to understand all these concepts once you complete the studying of this particular course. So let's go into the syllabus of this particular course, Computer Organization and Architecture. It contains 5 units. So coming to the first unit, it is divided into two parts. First part is the digital computers, where you are going to study about the introduction block diagram of a digital computer, as well as the definitions of computer organization, design, and architecture. And in terms of with respect to register transfer language and micro operations, you are going to study about what is the register transfer and what do you mean by register transfer language, as well as you are also going to study about bus and memory transfer, as well as different types of micro operations like arithmetic operations, logical micro operations, and shift micro operations, as well as a hardware unit called arithmetic logic shift unit. Coming to the second part of Unit 1, we're going to study about a basic computer organization and design, where you come across the instruction codes, the computer registers, computer instructions, and as well as timing and control unit of a computer, and how the instructions are executed by means of an instruction cycle, as well as memory reference instructions, input output instructions, register reference instructions. All these we are going to study here. Next, coming to the second unit, where which first it is also divided into two parts: microprogrammed control and central processing unit. As a part of microprogrammed control, you are going to study about the introduction of a control memory, as well as how the address sequencing is done in a control memory, and an example of a microprogram and how the control unit is designed. Next, coming to a central processing unit, we'll come across the register organization, how the general registers are organized in a computer system, uh, and as well as the different types of instruction formats and addressing modes that are available in the system. And apart from that, we are going to study about data transfer instructions and data manipulation instructions as well as a program control instructions. Coming to the third part, it mainly deals with the data. So how the data is being represented in your computer system. So first part is the data representation, where you come across different types of data. What are the different ways in which data can be represented, data types and complements, how the fixed point representation and floating point representation of data is done. Next, coming to arithmetic, where you are going to perform several type of arithmetic operations on the data which is stored in the computer system, such as addition, subtraction, multiplication, and division operation. And all these four operations are done on different types of data forms like a floating point data, sign magnitude data, as well as a decimal data. So all on this, how the arithmetic operations are done. Coming to the fourth unit, it is also again divided into two parts. The first is the input output organization, where you are going to learn about what is an input output interface, how the data transfer takes place in an input output organization, and what are the modes of transfer, as well as priority interrupts and direct memory access concepts. Next, coming to memory organization, where you are going to learn about memory hierarchy of different types of memories, and you're going to learn in detail about different types of memories present in a system like main memory, auxiliary memory, associative memory, and cache memory. Coming to the last unit, fifth unit, it is also divided into two types. The first unit mainly deals with the concept of architectures of computers such as RISC and CISC architectures, as well as it also deals with the pipeline processing and vector processing, which is the one type of method of executing the instructions in a parallel manner. So, reduced instruction set computer, you're going to study about RISC and CISC, characteristics of RISC and CISC. And in case of pipeline and vector processing, you're going to learn about what is parallel processing, and then we move on with the pipelining technique, different types of pipelines used, arithmetic pipeline, instruction pipeline, RISC pipeline. Then we move on with vector processing and array processing. Coming to our second part of fifth unit, multiprocessors. Here we are going to study about what are the characteristics of multiprocessors, what are the interconnection structures used in a multiprocessor system, interprocess arbitration mechanism, interprocess communication, and how the interprocess communication and synchronization is done in a multiprocessor system, as well as a cache coherence, the concept of cache coherence. So these are all the 5 units of your syllabus. Coming to a textbook, the best prescribed textbook for this is Morris Mano. The third edition, there are many latest editions. I think there are up to 7 editions, but the third edition is always the best. We can go for the third edition of Morris Mano Computer System Architecture. And coming to a reference books, you can also refer Karl Hamacher. That is also a good book, as well as William Stallings, 6th edition, and Structured Computer Organization, Tenenbaum. So these are all the reference books that you can follow. So we'll start with the first session. Today's session, we are going to discuss about the introduction to a computer and its block diagram. Coming to an introduction, so the word computer comes from a Latin word which is called as a computer. So which means to calculate, to count, to think, or to sum up. So the word computer means a device that performs computation. So more overall, it is an electronic device that processes the raw data based on the instructions which are given by the user. So a computer is an electronic device that performs a variety of tasks such as storing, processing, and outputting the data. Next, coming to the functions of the computer, it is responsible for 4 functions like input, storage, processing, and output. As a part of the input, it accepts the data or instructions through the input devices from the user. As a part of storage, it stores the data which is required for the future use. As a part of processing, it processes the data based on the instructions which are given by the user. As a part of an output, it produces a result. These are the main functions of a computer. Next, coming to the block diagram of a computer. A digital computer is a fast electronic calculating machine which accepts digitalized input information and it processes it according to the instructions which are stored internally and it produces the resulting output. So, if you see the block diagram of a digital computer, it mainly contains three parts: the input unit, CPU, and output unit. So, each and every unit is responsible for certain functionality. So, the input unit is responsible for receiving the input data from the user by means of input devices. And the CPU takes the input from the user which is and process it the data as well as the instructions which are being given by the user. So moreover, CPU is also called as the brain of a computer. And coming to the output unit, it displays the output results to the particular user, to the end user. Next, coming to the input unit, the functions of an input unit is to convert the input data into binary code. So here, the data which is taken as an input from the user, it is in the human readable form, like your normal characters or alphabets. So, but as a computer, the computer can only understand the data which is in a binary code in the form of zeros and ones. So, the main role of an input unit or a function is to convert that particular human readable code into a machine code or a binary code. That is done by means of an input unit. And it sends the particular data which is taken as an input from the user to the computer memory. The data transfer is one more function. So these are the list of input output devices that are present through which the user gives an input to the computer. It can be a keyboard, it can be a microphone, it can be a mouse or trackball, anything. These are the list of input output devices. Sorry, input devices. Next is the central processing unit. So the central processing unit or a CPU, it is also called as a brain of a computer. So the functions of the CPU is to control all the hardware and software as well as to control the flow of data. And it also performs operations, all the operations based on the instructions given by the user. And it accepts the data from the input devices and sends that particular data uh, uh, it accepts the data from input devices as well as it sends the information to the output devices, data transfer. And it executes as a part of program execution, it executes the programs which are being stored in the memory. And as a part of data storage, it stores the data whether temporarily or permanently. And arithmetic logic unit, it performs arithmetic and logical operations. These are the main functions of your CPU. So CPU, it is again classified into three parts. If you see, it is divided into three parts called the arithmetic logic unit or ALU, the control unit, and the memory unit. So it is classified into control unit, arithmetic and logic unit, and memory unit. As a control unit, it manages the computer components, interprets the instructions, and activates the other parts. So, as a part of arithmetic logic unit, it performs arithmetic operations as well as a logical operations. So, arithmetic operations like plus, minus, into, divided by, whereas the logical operations like greater than, less than or equal to, and greater than or equal to. Memory unit, it stores the data in instructions temporarily or permanently. So, we'll see in detail the control unit. The control unit manages the computer components. So it reads the instructions from the memory, interprets them, and sends the signal to activate the other parts of the computer. So based on the instructions which are being stored in the memory unit of the computer, the control unit is going to understand or interpret the information present in the instructions and understand what the operation has to take place. And based on that, it sends the signals to all other parts to perform that particular operation, and it controls and coordinates the input output memory as well as the other units of the computer. So this the control unit is mainly responsible for providing a coordination between all the parts of the computer for the smooth execution of your user programs or instructions given by the user. Next comes arithmetic and logic unit. It performs basic arithmetic operations like addition, subtraction, multiplication, and division. And it also handles logical operations like greater than, less than or equal to, or greater than or equal. Next part, important unit of your CPU is the memory unit. So the memory unit of a computer is used to store the data and instructions before and after processing. So once a user gives the input data and instructions that need to be processed, that are first being stored in the memory unit, and they're being processed or executed by the CPU. And once the execution is over, the results are again being stored in the memory unit before giving it as an output to the user. So it is responsible to store the data and instructions before processing and after processing. And memory unit is classified into two parts: the primary memory or a main memory, or and the secondary memory. So if you see here, the memory, it is divided into primary and secondary memory. The example of primary memory are your RAM, random access memory, and read-only memory. And examples of secondary storage devices or secondary memory are the hard disks, compact disks, DVDs, and floppy disks. So, what is the difference between the primary memory and secondary memory? So, there are two types of memories present in the computer. The first is the primary memory. So, the primary memory is also called as internal memory or main memory or volatile memory. So, this is one of the computer memory that is accessed first or directly by the processor or a computer. Here the processor means the CPU. So whenever a CPU wants to execute a particular instruction, whatever instruction that is stored in the memory, it has to be present in the primary memory. The primary memory, so that the CPU, because the CPU can only access a primary memory directly, it cannot access a secondary memory. So in order to execute a particular instruction, it has to reside in the primary memory. And the reason why we call this primary memory as a volatile memory is the data is stored temporarily in this memory. You cannot store the data permanently in the primary memory. So once the power is switched off, data will be completely erased. So it is called as a volatile memory. Example of a primary memory is your random access memory. Next, coming to a secondary memory, it is also called as non-volatile memory. Why we call it as a non-volatile memory is because it stores your data as well as your programs permanently, even when the computer or power is turned off. That is the reason we call this memory as a non-volatile memory. It is non-volatile in nature. So it is also known as auxiliary memory or external memory or even non-volatile memory. And examples of secondary storage devices or secondary memory are your hard disk, your compact disk, flash drive, or pen drive. These are the examples of secondary storage devices. Next comes the output unit, which is on the last, according to the block diagram. The, the third one is the output unit. So the output unit of a computer. The function of an output unit is to accept the data from the computer memory. So the results of processing, the results are stored back into the memory unit. So it takes or accepts the data which is stored in the memory unit of a computer. And we already know that whatever data that is present in the computer, it is in a binary code. So the output will be obviously be in a binary code. So, but the user cannot understand the binary coded information if you give it as an output. So the data conversion is done by the output unit. It converts that output, which is in a binary coded form, into a human readable language before giving it as an output to the user through the output unit. So it converts the binary coded information into a human readable language. That is also one more function of the output unit. So the functions of the output unit are: it converts a binary coded information into human readable language or inputted language, and It accepts the data or information from the main memory of your computer. So coming to the examples of output devices through which the user gets the output from the computer: the speaker, headphones, monitor, printer, projectors, plotters. So these are the different types of output devices available in your computer. So you can see in detail about the different types of output devices: the touch screens, monitors, speakers, projectors, sound cards, headphones. So all these are some of the list of output devices available. Thank you.